That's the question we are having. Cos 2x by cos x plus sin x whole square. Now the question is how to again express this cos 2x, because there are three formulas for cos 2x as I told you earlier. So cos 2 theta formula. So there are three set of formulas. That is cos square theta minus sin square theta is one formula. You have 2 cos square theta minus of one another formula. 1 minus 2 sin square of theta is another formula. So now the question is, out of these three formulas, we already used these two formulas and we have done the examples. Now the question is, should we continue with these same two formulas over here and proceed further, or we have to do something different? For that, you have to observe the denominator. If you try to see the denominator is in the form of cos x plus sin x. That means both cos and sin are there. So in the numerator also, you have to get both cos and sin. Both cos and sin are there only in this term. Therefore, I have to use this formula rather than the other two. The two formulas, even though we have used in the other problems, here we cannot use it because of the denominator which is there. Or if we try to rewrite this one, I'll think is equals to, it is integral of cos 2x divided by cos of x plus sin of x whole square times of x. So now we'll try to replace this cos 2x. So cos being of cos square of x minus sin square of x, and is whole divided by the denominator, this cos of x plus sin of x whole square times of dx. If you try to observe the numerator is for a square minus of b square. So which can be written as a plus b into a minus of b. Which can be written as a plus b into a minus of b. So if I just try to plug in over here and use the formula, that is a plus b cos plus sin x, a plus b into a minus b cos x of sin x is b into a minus of b divided by cos x plus sin of x whole square times of dx. Now you can observe that one of the value cos x plus sin x and one cos x plus sin x, both in the numerator as well as in the denominator, will cancel out. So you just left out with this particular value. So the integral of cos of x minus sin of x of x sin of x into dx. Now the question is how to integrate this one. Is it possible to integrate directly? So you can go ahead with the substitution method. So put the denominator as t so that its differentiation will be present in the numerator. So if you try to differentiate, cos differentiation will be minus sin x, and sin differentiation will be cos of x. X is dx is equal to d. Or first you write down the positive value cos x, then you write down the negative value minus sin x into dx is equals to dt. So is this not the numerator value you have? So cos x plus sin x into dx is giving us dt, and the cos x plus sin x value is giving us t value. Therefore, what is integral of dt by t? So we know this formula, integral of dx by x will always be nothing but log of mod x plus the constant of integration c. Therefore, you'll be getting log of mod t plus the constant of integration c. But we know that we have taken t value to be equals to cos of x plus sin of x plus the constant of integration c. So that will be the required solution.